Hello, this is day 2. And so day 2 in Honors Physics is talking about conversions. So what we're going to do is we're going to go and you had to read the section. Let's look at our agenda. Let's change over to Physics Honors. Let's go to our classwork. Let's go to our weekly agenda. Here. Let's go to today. All right. So for day 2, it's telling us that we should be able to interpret data in tables recognizing equations that summarize data. So the first thing you have to do is fill out your table contents. That's what we did at the very beginning where we have the reading assignment. So we have a reading assignment that we have to do for an article after we do page 10 through 12. And then we have some guidelines to a rubric, an outline, and then we have a quiz today. So let's go first of all to the reading assignment 1.2, 10 through 22. So I'm going to go ahead and go back here to Spear. I'm going to go back to my ISM book and we're going to talk about it. So in the reading assignment, it talked us about what dimensions were. When we're talking about dimensions, we're talking about length, we're talking about mass, and we're talking about time. The units are meters, kilograms, and seconds. We're also talking about force, velocity, energy, volume, and acceleration. Okay? So the first thing is talking about how much. So when we're talking about how much something is, we can specify physical quantities in that, and that units of dimensions is going to be of time, can be in seconds, hours, and years. So based on that, we have to understand what SI units are. So when we're talking about SI units, we had a data table, and what I did is I just copied it down with the exponents, what the name of it was, and what the symbol was for the very small numbers and very big numbers. So when you're converting units, you need to cancel. So say we want to take 27.2 millimeters and we want to change that to meters. So what we're going to do is we're going to do 37.2 millimeters times, all right, how many meters is that in a millimeter? Well, let's look up here. So we need to do that by 10 to the negative 3, because that is the millimeter, right? To our meter. And then over 1 meter. So, in our calculator, when we're doing this, we will need to do 37.2. We can do an open bracket if we want to. Alpha y. And we're going to do 1 because we're going to do a fraction, right? 10 to the power of negative 3 over 1 over, close our bracket and hit enter. And I get 0.0372. Now, we're going to do the conversion of that. And remember, if we're moving our decimal over 2 places, that's where we get 3.72 times 10 to the negative 2. Okay? So then we have to have both units have to agree when we're doing conversions. So the first thing that we have here is we have a sample problem. So in our textbook, the sample question, which is this one right here, says that a scanning tunneling microscope, STM, has a magnification ability of 100 millions and can be distinguished between two objects that are separated by 3.0 times 10 to the negative 10 meters, or about 1/100th of the diameter of an atom. Express the 3.0 times 10 to the negative 10 meters in nanometers and in pictometers. So the first thing we're going to do is we're going to write down what our given is. So our given is 3.0 times 10 to the negative 10 meters. And we need the distance in nanometers and pictometers. So based on that, what we're going to do is we'll use our chart here. So we're going to say 3.0 times 10 caret negative 11 over, open bracket, alpha y inner, and that would be 1 over 1 times 10 caret negative 9 over, close my bracket and hit enter. And I get 0.03 nanometers. Okay? So then the next thing I'm going to do is I'm going to do my 3.0 times 10 caret negative 10 over, open bracket, alpha y inner, 1 over 1 times 10 caret negative 12 over, close my bracket, and I get 300, which if I'm doing that, I would move my decimal over 2, which would be my 3.0 times 10 to the second power. So now let's look at the practice problems. So on our practice problems, it says a human hair is approximately 50 UMs in diameter. Express the diameter into meters. So we're going to say, all right, it is this unit here, and we're going to meters. So to be able to do that, we have to look up on our chart, and there is our micrometer, which is 10 to the negative 6. So what we're going to do here is we're going to say, all right, 50, open bracket, alpha y inner. We're going to do 1 times 10, and then it's going to be a caret negative 6 over, down, over 1, over, close bracket, enter. And I get 5 times 10 to the 5th power. Okay? Next one. Number 2 says, if a radio wave has a period of 1 unisecond, what is the wave period in seconds? So I have 1 with the seconds, and I want to go to seconds. To be able to do that, I'm going to also use my 1 times 10 to the negative 6 power, and I'm going to do 1, open bracket, alpha y enter, 1 times 10 caret negative 6 down, 1 over, close bracket, and I get 1 times 10 to the negative 6. Number 3. It is estimated that the sun will exhaust of all the energy in 10 billion years. By the time it had radiant over 1.2 times 10 to the 44th joule of energy, express this amount of energy in kilojoules. Here's what I'm having. This is where I need to be. And I'm going to let you do number 3 and 4 on your own. Number 5 is talking about a practice problem where it says the Pacific Ocean has a surface area, and you have to find the circumference of that. I'm going to change my page because I should have just covered it up instead of showing you the answers, but I would like you to work those problems by yourself. The next thing we're going to do is we talk about the difference between accuracy and precision. Accuracy is how close you are to the accepted value, and precision is the degree of exactness of a measurement. The next thing that it tells us, it talks about error, like method error, different methods that you use, instrumental error, maybe your instrument's not working correctly. And then the next thing it talks about is it talks about significant figures, digits that you know with certainty, plus the first digits of uncertainty. Here is something really major for you to know. So what I would do is I would get my highlighter. I'm going to use yellow because I think it's important. And these are the rules of SIGFIX. So the first one says 0 between a non-zero digit are significant. So they gave us an example of 50.3. There's 3 SIGFIGs here. 3.0025, there's 5 SIGFIGs here because there are zeros in between other digits. 0 in front of a non-zero digit is not significant. So if it's like 0.892, there's only 3. If it's 0.0008, there's only 1 sig fig. Number 3 rule. 0 at the end of the pound also have the right of the decimal is significant of this number. 57.00, it's a placeholder, so there's 4 sig figs. 2.000000, there's 7 sig figs because it is also a placeholder. Number 4, 0 at the end of the last decimal is not significant. So 1,000 would not be significant, and 20 would not be significant. There are also other rules with adding and subtracting and multiplying and dividing. So when you are doing addition, what you're going to do is, if you see how this one here has 2 digits after, that's what you're going to do here for your answer, okay? But with multiply and division, remember, see how there's 3 here, but there's 1, 2, 3 there at the end? See how we're rounding it here. Calculators do not pay attention to sig figs at all. They just give you a number. So when you have to figure out if you're rounding down or rounding up, if your number is 0, 1, 2, 3, or 4, of course you're going to keep the number, like for example 30.24. This is a 2, so I'm not going to round up to 30.3. Okay, that's what it's talking about here. If it's 6, 7, or 8, and if the last sig fig digit is 5, you got to look at the next one to find out if you round up or not. So 22.49, you look at the 4, the 9 tells you to round it up to 5. Okay? And then so on. You will use these rules throughout the year, so you want to make sure you can get to it. And then we talk about mean, mode, and median. When you're doing a mean, you're going to take the sum of the values and divide it by the number of values. When you're going to do a median, you're going to put them all in order and what's in the middle. And when you're going to do mode, that's where you put all your numbers down and find out the one that appears the most. Okay? So standard deviation and normal deviation outliers. And then the last thing that we want to talk about is we want to talk about percentage error. Cover some things up. So when we're talking about percentage error, we're talking about the value that is experimental minus the value that was accepted divided by the value accepted times 100. What do I mean by that? Value experimental is what you actually got. So if you got 10 liters, okay, in your experiment, but the value expected was supposed to be 1 liter, okay? This is what you would use for that. Now what I'm going to do is I'm going to do the review questions that are at the end of this section. So let's look at them. Those are going to be on page 22 in this formal assessment. The first one asks you, it says, what is the SI unit would you use for the following measurement? Length of a swimming pool. That's mass. That would be milligrams. The mass of the water in a pool. Excuse me. That would be in kilograms. And then the time, of course, would be in seconds. So number 2 says, express the following measurements as indicated. So the first one here is you're going to have a mass of 6.2 milligrams. And they want to make sure that you put it into kilograms, okay? So if we're doing that, we're going to say 620 milligrams over 1 times 10 to the negative 3 grams over 1 milligram times 1 kilogram over 1 times 10 to the third power of grams. What we want to be able to do here is we will want to be able to cancel out. So here, milligrams cancel out, grams cancel out, and the only thing we have left is kilograms. So if we have our calculator, we're going to have 6.20, open bracket, alpha y, enter, 1 times 10, caret negative 3, over 1, over, close bracket, open bracket, alpha y, enter, 1 down, 1 times 10, caret 3, over, close bracket, enter. And we get 6.2 times 10 to the negative 6. Okay? So that is A. Now, B's asking you to do 3 times 10 to the negative 9. C is 88.0 kilometers per meter. I'm not going to do those for you. I'm going to let you do those for homework, and then I will come back in class and we'll go over those answers. So then now what I need to do is figure out how to do this. Now what I'm going to do is I'm going to go to question number 3. Question number 3 says, perform these calculations following the rules of significant figure. 26 times 0.02584. So when you multiply that, you should get 0.67184. Since it's multiplication, the smallest number is 26, so that would be 0.67. I would like you to do B, C, and D also. So what you need to do is you will need to do those other problems that I did not do. When you get done with that, then we'll probably go over them on a Friday, online if we need to, or tomorrow is Wednesday, and we might go over them Thursday so that you can take your quiz. But this here is the end of this lesson. The only other thing that you have to do after you do your practice problem is it also has you doing a reading article. We're going to talk about the reading article in class, and what you would do is you would open this up and you would read it, and you would just do a paragraph on talking about what this was and how does this relate to what we're doing in science, and I will share that with you in class. And then also on here, let's see what else we've got. It says guidelines and rubric, which I'm going to give you. That's for the article analysis, which you got to figure that out. And then the last thing it says online quiz section 1.2, and you will go here. You have 59 minutes to do it, and you will choose the answers and you will get a grade. Once you get a grade, then you're going to score your test, and then you're going to do a screenshot, or better yet, I think I get to score it. So that's what you're going to be doing on Thursday afternoon. I will see you in class, and I hope you have a good day.